Big week for desktop and production AI. NVIDIA introduced Nemotron 3.5 Lightning. It is a 30 billion parameter mixture of experts model. It uses 3 billion active parameters and a 1 million token context window. NeMo Switchyard arrived as a routing library for agents. LTX released LTX 2.5 for local video world modeling. Xiaomi published Prove, new perception-aligned metrics for object removal. An OctoBot tutorial shows a disciplined walk-forward research pipeline. These releases target layers of the same stack. Nemotron Lightning focuses on high-volume agent execution. NeMo Switchyard routes routine calls to efficient models. LTX 2.5 targets local multi-shot video generation on RTX. Prove introduces local spatial and temporal metrics for object removal. OctoBot supplies a reproducible engineering template. Nemotron 3.5 Lightning is a 30 billion parameter MoE model. It uses 3 billion active parameters. The architecture mixes Mamba 2, MoE, and Attention. Pre-training covered more than 20 trillion tokens with an NVFP4 recipe. It supports a 1 million token context window. Published BF16 results include MMLU Pro around 81.94 and GPQA Diamond about 75.44. NVIDIA reports up to 4x faster output and 30% faster completion on 10,000 PinchBench tasks versus Qwen 3.635B. Weights and recipes are available under OpenMDW 1.1, according to the source. NeMo Switchyard is a routing library for agents. It provides tuning-free routers and an escalation router. Stage routers inspect recent tool activity. A prefill router can learn from the model residual stream. A LangChain benchmark of 145 tasks reported a 74% cost cut when routing Lightning and Claude Opus 4.8. About 7% of calls went to the Frontier model, trading roughly 6 accuracy points versus a Frontier-only baseline. LTX 2.5 targets creators and small teams. A 10-second clip took 6.8 seconds on-prem, with 2 GB200 GPUs in LTX benchmarks. Via the LTX API, the same clip took 23.7 seconds. LTX reports these runtimes and claims large speedups versus closed alternatives. LTX 2.5 runs on consumer NVIDIA RTX GPUs and ships open weights on Hugging Face. It integrates with Comfy UI and is free for organizations under $10 million ARR. The LTX family reports over 33 million downloads according to the source. Opportunities are concrete. Creators can batch generate variants locally with LTX 2.5. Product teams can cut agent cost by staging models with Switchyard. Prove gives a reference-free metric for object removal quality. OctoBot shows how to validate and avoid overfitting before deployment. Prove tackles object removal evaluation. It supplies RCS for spatial coherence and RCT for temporal consistency. Both use sliding window maximum mean discrepancy on Dino v2 features. They do not require a reference video. In reported human tests, RCS achieved higher average Kendall's tau and Spearman's rho than Remove and CFD. Prove is available as an Apache 2.0 PyTorch repo and includes PinchBench. RCS uses connected component analysis to split targets. Each bounding box is expanded by roughly 1/3 of its side length. A sliding window computes maximum mean discrepancy between masked and local background features in Dino v2 space. RCT crops adjacent frames under the union of masks and computes MMD inside the intersection. Reported ablations show Dino v2 Giant outperforms Dino v3 and SAM, and RCS is faster than CFD. OctoBot supplies a reproducible research pipeline. The tutorial creates an isolated Python environment and pins dependencies. It defines an RSI plus EMA strategy with ATR-based stops. A grid search runs on an in-sample window. The chosen parameters are validated on a separate out-of-sample period. Results are exported as JSON and turned into interactive plotly charts. Inspect parameter surfaces and use walk-forward validation to avoid overfitting. There are trade-offs to consider. Routing reduced cost but lowered accuracy in the reported benchmark, about 6 points for 74% cost savings. MoE models use active parameters. Lightning reports 3 billion active parameters out of 30 billion total. Local world models require GPU resources. LTX reported on-prem runs using 2 GB 200 GPUs. Proof depends on Dino v2 features, so other feature backbones may change results. Bottom line: open, hardware-aware models and better evaluation enable local production AI. Nemotron Lightning and NeMo Switchyard aim to lower agent cost and latency. LTX 2.5 enables fast, consistent desktop video generation in reported benchmarks. Proof provides perception-aligned metrics for object removal. OctoBot demonstrates reproducible, walk-forward validation. Prioritize measurement, staged model stacks, and reproducible tests before scaling. You will find the sources in the description. Check Nemotron on MarkTechPost for model cards and benchmarks. Open the Proof GitHub and paper for code and PinchBench details. See LTX 2.5 on Hugging Face and the OctoBot tutorial for runnable examples. All links are in the description.